Thank you for having me here and for taking the time. I have a presentation prepared to talk a little bit about Floodlight, our company, why our company does Floodlight, or why we contributed it to the community, and just a deep dive into the architecture of it and the programming model. And this should be interactive, so if you have any questions, in our definition of SDN, if you have any questions, just feel free to call out. Especially if I can't see you from here, so just feel free to call out while I'm talking. There's about 30 slides or so. Just really quickly, our company is a couple of years old. We're based in Palo Alto, California. We were founded by some of the people that Ray worked with at Stanford, one of the leaders of the Clean Slate Lab, Guido, and one of the authors of OpenFlow is our CEO. And we have on our engineering team a number of people that have come from Cisco, VMware, and Arista. Our VP of Engineering built the virtual switch for the ESX hypervisor, and then we have people that are on the chairs of the ONF and architects of the OpenFlow protocol. So there's typically in Silicon Valley you have really smart people who go from company to company, and knowledge of networks is limited. It's very hard stuff. And so typically, in order to be successful, you'll try and get some of the people that have done it before. So the reason why all this matters is because the network and the way that networks are delivered to enterprises, and our company sells software to enterprises. So we sell to organizations that want to solve the problem of being more efficient in how they use their data center resources, their compute and storage. And typically, this is how companies like Cisco sell their products. The controller is in the center there somewhere, but they've built proprietary hardware and software and applications that all come delivered in this one box. But what's happening now is with the advent of a number of protocols like OpenFlow, but not only OpenFlow, is that we're able to separate the data plane, the hardware that actually moves packets around, from the logic that controls how those packets move around the network. So the controller is being lifted out, and this is kind of similar to what happened in the 80s with anyone who's old enough to know the old IBM mainframes that were delivered in the same way gave rise to with Microsoft Windows, and then the Linux operating system became free operating systems that then applications could be written on top, and that essentially drove the cost down for everyone for computers that could be built for really, really cheap amount of money. So we're seeing kind of the same thing happen in networking today. And so OpenFlow, can I just see a raise of hands if you've heard of OpenFlow in this room? So there's a huge number of people. So for the people who don't know what OpenFlow is, it's a very basic protocol that defines a communications channel between a switch and a controller. And we'll talk about what a controller does, and that's what Floodlight is. But OpenFlow basically implements an encrypted channel using TCP and SSL from the controller to a switch, and on the switch runs a software agent that implements basically a table that enables you to do a match and then take an action based on that match. So essentially, any packet that comes into the switch, it will look at its table, and depending on whether or not the switch knows what to do with that packet, it will either do what its table tells it to do, and that's things like send it out for support, or drop that packet, or or rewrite the header, or if it doesn't know what to do with it, it'll ask the controller for instructions, and the controller will tell it what to do. So so you get really fine-grained access to what's happening on the switch. So just to look at an example of that, say a packet enters a switch. In this case, it could be a vSwitch, like Open vSwitch, that runs on a hypervisor. The packet header is forwarded to the controller, and the controller, does a lookup and says, what do I do with the switch? It'll send a flow mod down to the switch to tell it to, do whatever the logic tells it to do. And all subsequent packets that come into that switch are then switched at line rate, because now the switch will, is going to handle that in hardware. So it'll, just update its TCAMs accordingly. And it's possible to also do this proactively in order to, there's a cost to the packet ends, because essentially you're incurring latency of the packet to the controller and then having the entry come back. So, and so you want to avoid that as much as possible. A little bit about OpenFlow. We're currently on version 1.3, although the majority of the implementations out there are 1.0, and that's what Floodlight supports today. Although there's work happening for 1.3 and 1.2 support as well. So our definition of SDN looks like this. Essentially it means that you can create, this API now interface to your controller. So you can write programs to get the state of the network and push logic down into it. And so with that, you can, imagine that you can write applications on top of this controller. And some examples of applications are virtual switches, routers, load balancers, layer 4 through 7 services, other security services that can leverage, a programmatic interface to the state of the network. One example of, what you can do with a program like that, or with this is on the left is a typical example of the configurations that you have to put in place to just set up a simple trunk across 3 switches to trunk 2 IP addresses together. And on the right, this can be done very, very simply with Floodlight and with and with SDN. And the power of this is that if you actually move the host from one port to another, the system will, it will see that automatically and then reconfigure the network automatically. So there's no need to actually reconfigure things. And so this can be done with scripts, and a lot of operators today will use scripts and expect scripts and CLI tools to actually kind of accomplish the same thing. But that solution doesn't really scale, and it's very, very hard to maintain. One of the things that we see when we go into customer accounts is just the very act of doing a show network command, where you just kind of do a show on the controller, and it lists all the hosts, all the IP addresses, and all the MAC addresses across 100 switches in your network. Is something that even that level of visibility into a network is not typical at all for operators. Typically, they have to open up a ticket to the data center team to go and get that data and get it back like a week later. So it's really, really important for operations as well. So any questions or comments about that? While I'm talking. So yeah, just a little bit about what I talked about. Programming a distributed control plane is hard. Not too much more information here. So our company has open sourced a number of projects. Floodlight is the core of our commercial product. Our commercial product implements additional features that are not in Floodlight, and those are things that enterprises need, like high availability, the ability to run in an active standby mode, so if one box goes down, the network doesn't go down. It implements persistent storage that's not in Floodlight today, so if you reboot the Floodlight controller, all your configurations may get lost. And there's other things like a command line interface that enterprises really need. We also have a project called Indigo. I don't know whether or not there's any kind of people here that would be interested in contributing to Indigo, but what that is a framework. And I'm not going to get into this very much, but I can certainly point you to more information after this talk. Indigo is a framework to enable OpenFlow on any physical or a virtual switch. So it's implemented in C, and it establishes a layer of abstraction between a forwarding plane and port manager of a switch versus the OF OpenFlow configuration and UI pieces, and implements libraries to speak OpenFlow. So you still have to do work to integrate it with your switch, but Pronto and Netgear have actually used Indigo to OpenFlow enable their switches. And so, what our company does also is we try and work with any switch vendor that wants to support OpenFlow because it helps us, and that there's a larger footprint of available OpenFlow deployments out there that helps our company. And then OFTest is a framework just for OpenFlow compliance testing. So you point it at any OpenFlow switch, and it'll tell you whether or not it's compliant to the specification. The problem with the 1.0 spec is that it doesn't cover all the cases. It's not a very tight specification. So, for example, it doesn't really define what happens if the switch, or if the controller goes down, whether or not the switch remain active, fail open or fail closed. So that's up to the various implementations to decide what to do. And so this is how all those projects fit together. That you run Floodlight OVS, which is not our project. It's something that VMware owns today. And the various applications on top. A little bit more about Floodlight. It's an Apache version 2 license controller. Do we all know what that means? Apache version 2. It's basically an open source license. It's one of the most permissive licenses. It basically means that you can take the code, and then you can do anything that you want with it. You can sell it, make money on it, and not have to give those changes back. Although we obviously encourage contributions to the project because it makes the project better, but it's the most permissive license out there. It's implemented in Java, and it uses a modular framework for the capabilities, so it's really easy to add new features to, and it supports a number of switches that I'll have a list of later. Today, it's the most popular open source controller on the market. The others are Trema and Nox, and there's one in Asia called Ryu. But up until, and these slides weren't updated after July, but up until now we have about 9,000 downloads since the beginning of the year. Just a graph of the growth and graphs. This is a list of switches that support OpenFlow. I know that we here use NEC and Prontos. This came from Interop 2011, and so a lot of these companies haven't released products yet, but Brocade, Extreme, HP, and Cisco has even announced that they're going to release an OpenFlow switch, and so some of these are not on the market yet, but they're coming. And most companies and organizations that have downloaded Floodlights so far. A few sample applications, that have been written, in addition to what Ayaka has written, the integration to FlowVisor. There's also a number of projects, and this is not a complete list. Floodlight has a plugin to Quantum that I hear some people here might be using. It's implemented as a REST proxy interface. Quantum is not really, is just a shim. Quantum doesn't actually do anything by itself, so it needs a controller to actually manage the network. And so we've delivered a plugin that sits on the Quantum server that will take in API calls from Quantum and then translate them to an application called Virtual Network Filter that implements very, very basic layer 2 isolation, unicast only, for creating layer 2 domains within an OpenStack deployment. There's also a little laugh that one of our engineers wrote that is an iOS app that implements a very basic patch panel, so you can actually just kind of take 2 ports, hit a button, and then it connects 2 ports together. Not that useful except as a showcase, but of the power of the REST API. And there's a couple of companies that are building products on top of Floodlight as well. VRHR is one started by a couple of the founders of NetScreen. So building Floodlight's really, really easy. It's all the code's up on GitHub or on floodlight.openflowhub.org, and I'll provide these links later. It's a Java It's a jar, so it needs a JVM to run. I recommend that you just get the entire VM that's also posted on the website. That includes the pre-built package and also Mininet, which is a network simulation tool that lets you simulate having a lot of switches running on your laptop. It kind of implements a switch and as a Linux process, Unix process. So it's really easy for testing and simulation. Is there a question? So the latest release was a few months ago, where we rolled out a module system to make it really easy to plug in new modules. As of next month, Floodlight is going to be packaged in Ubuntu, and so you'll be able to do apt-get install Floodlight in order to install it on Ubuntu systems. And we're going to be doing another release in about a month or two that's going to implement some additional things, some housekeeping things like a test framework and a firewall system, and a lot better documentation is coming as well. So just a little bit about the architecture. It's just a collection of modules. Some of these modules export services that other modules use. It's all written in Java. And a lot of the modules interfaces are exported via REST API. So I'm going to go through each of these modules and then show a picture of how the architecture is all laid out within, within the project. So the Floodlight provider module, kind of simply sits there and translates OpenFlow messages into events that then other modules can access. It manages the connections from, basically from the controllers to the switches. The topology manager keeps an up-to-date topology of the network underneath it. So it will compute the shortest path between each of the switches that are connected to the controller, just using simply the Dijkstra algorithm. It's really easy to add or to implement a new forwarding or a new, well, there's a forwarding module that I'll talk about. Link discovery does just that. It'll give you an alert whenever a new link is identified or goes down using the LLDP protocol. The forwarding module will install flow mods for end-to-end routing. So basically, this module is loaded by default, and I'll show just a quick kind of an example later of a hands-on demo of this working. The forwarding module, every time it sees an ARP request from a host, it will add a flow mod into the controller for that endpoint, so that you can ping hosts that are plugged into your switches, which is kind of confusing at first because it shouldn't do that. So I'm going to show you an example of having it there and then not having it there, and then what happens in the logs. The device manager will track all the hosts on the network, so it's basically a huge, distributed CAN table that just lists where all the hosts are and what and their IP addresses and MAC addresses, virtual or physical. The storage source interfaces are there, but there's no like implementation of the storage right now. And so if you wanted to build and integrate and sort of implement this, very simply by using a SQLite database or even writing to flat files, you could use this interface to do that. The REST server is used to expose these interfaces via REST. The static flow pusher supports the insertion and removal of the static flows. So this is what you use to push flow mods down into the controller. And the virtual network filter was written for the quantum integration, and it lets you create layer 2 domains per MAC addresses. So if you were to take all those modules and diagram them, there's 3 classes of things here, and I know it's kind of hard to read, but on the bottom right is what we regard as the core controller, and that's the device manager and the topology manager, as well as all the bits that speak OpenFlow. And there's 2 classes of applications. When we talk about applications, and this is and so applications are really where a lot of the solutions come from, right? Users of this don't really care about the programming model. They just want to actually deploy this and use it. The REST API is not complete today, and so it will be in the future, but it doesn't handle things like packet ends. You can't really handle packet ends or rewrite headers via the REST API. So if you're writing an application that needs that level of access, you'll implement it as a Java module instead. And so that's why there's module applications implemented in Java, and there's a number of REST applications as well. Like I said, we're moving towards everything being implemented in REST because that's just a much better way to think about writing applications, because it doesn't dictate a programming language or a programming style, and it's completely agnostic to the implementation of sort of underneath it. You don't have to know Java, and so there's a lot of applications written in Python or other languages. And so that's something that our team is working on developing a proposal for this year, and the REST API will be delivered hopefully in a couple months. Just really quickly, what the REST API can do. This is not a complete list, but it can list hosts, links, list all the switches, look at counters, manage flows, and virtual networks are what you can do with the virtual network filter. So it's a really, really powerful API. It looks, it's simple conceptually, but it's really, really hard to implement. So that was, I think, the end. Pretty quick. If you want to get involved, go to the website and sign up for the mailing list, or send me an email if you have any questions. The best way to get answers to your questions is by emailing the developer mailing list. There's people from our team and others in the community on there all the time that can help sort of answer questions for you.